Well, good afternoon, everybody. My name is Adam Kingdon. I'm the CEO and co-founder of I2O Water. And we've developed innovative new technology for optimizing the pressure in the water distribution network. And as Ken mentioned, the I2O technology is one of the key building blocks in creating smart water networks. Why is it so important for a water utility to get the pressure right in the network? Well, firstly, it affects leakage. And as most people know, leakage is a massive worldwide problem. And as water becomes more and more scarce in different parts of the world, it becomes a problem that's even more important to solve. Pressure impacts burst rates, and bursts cause a huge disruption to the public, as well as to water industry customers, and over 30% of bursts don't even make it to the surface, so they can carry on running for months, if not years. Pumping water around, water is very heavy, pumping it around is very energy intensive. We estimate that over 4% of the whole electricity used in the US is for pumping water. Now, if you can pump water at lower pressures, and you can pump less water because you've got less leakage, then you can reduce that energy consumption. As we all know, and particularly all those of us in London, the water networks, the assets, are very, very old. A lot of them are currently at the end of their life, but it's completely uneconomic to replace the whole water network. Thames Water have spent around £1 billion recently, over the last few years, just to replace 7% of their network. And the guys at Thames Water also say that even if they had more money, they couldn't replace the network faster because the whole of London would come to a complete standstill. So replacing the network is not an option, and anything that can increase the life of those assets and those pipes is very valuable. And optimizing the pressure in the network can extend the asset life of those pipes. It also impacts on customer service. If you have less bursts in the network, then you're going to cut off your customers less often. And also, if you can give the customers the pressure they need when they need it, you're going to have less complaints for your customers. You're going to increase your customer service. So if optimizing the pressure in the network is such an important thing to do, why isn't everybody doing it? Well, actually, it's a more complicated problem than you might imagine. This is a typical water distribution network. Most water distribution networks, certainly in the UK, are divided into what are called DMAs, zones with about 1,000, 2,000 properties. They're often fed through a pressure-reducing valve. That's a big lump of iron, so by the side of the road, adjusted manually. If the water company wants to adjust it, they send someone out in a truck, lift off the manhole cover, and get into the hole with a spanner. So they're not adjusted very often, if ever. The DMAs are fed from a trunk main, it could be 10, 20 kilometers long, in turn fed from a distribution pump. And the guy running the distribution pump, he's got no visibility in almost every water company that we've come across. He's got no visibility of what's going on in the network. So he just pumps water out into the network at a fixed pressure, and he might drop it down a bit at night. So you've also got varying demand during the day, varies hugely from morning till night, and you've got varying demand seasonally. So you can see that all adds up to a very complicated problem, and there's no way that a water company is going to be able to optimize the pressure in their network using the current manual methods that they employ right now. So, yeah, this also explains another way of explaining why it's a little more complicated than it first appears. The graph on the left, the blue line is the inlet into the DMA. That's the pressure from the PRV. The red line is sort of the minimum pressure that you want to provide every house in your network. And they tend to set the blue line, so the green line is the pressure in the network at some point a couple of miles away from the PRV. As you can see, the green line varies up and down during the day. So first thing in the morning, everyone jumps in the shower, the pressure falls through the floor, and a lot of people in London complain because they've got too low pressure. At night, nobody's using any water. The pressure goes right up at night, and that's where all the bursts happen at night. And so you see all the shaded area under the green line is excess pressure, so it leads to excess bursts, excess leakage. So really what you want to do is, on the right, you want to continuously adjust that PRV all the time, so it's giving just exactly the amount of pressure that your customers need, but not more than they need. So I2O have developed a hardware and software solution to this problem. Sorry, it's a very complicated diagram. Firstly, we install sensors on the network that are measuring the pressures and flows. We install controllers of the PRVs and the pumps, and the sensors and controllers upload data, typically once a day, to our servers. And our servers got sophisticated software on it, which develops control models, which are then downloaded, typically on a daily basis, back down to the PRVs and the pumps. And that's basically a set of instructions telling the pumps and the PRVs exactly what pressure to be set at this time of day, this flow rate. And those models are updated on a daily basis to take into account of seasonal changes, changes in use, etc. And all that data is sitting on our server. We also provide that to the water company into their systems if they've got their own software, or they can see all that data, which tells them how their network's performing, if they've had bursts, if they had failures on the network, etc. So the I2O technology provides 6 main benefits to the water company. Firstly, the leakage, also reduced burst frequency, we save energy, customer service is improved, we extend the life of the network, and we also, all that adds up to lower operating costs. And typically our customers are getting under a 1-year payback on the installation of the technology. In fact, we had a CEO from one of our Malaysian customers visit us this week, and he said he was very proud that he'd achieved a 3-month payback on our technology, and we're trying to keep that extremely quiet from our VC backers. So we have our technology now installed with 40 utilities around the world in 22 different countries. And just give you maybe 3 quick examples of the benefits that our customers have seen from using the technology. And the first example is Shabas. It's the largest water company in Malaysia that supplies the KL and the KL region. And I mean, when they came to us, they had a big problem because they'd completely run out of water treatment capacity. And they had about 2% margin, and it's going to take them 3 years to build another water treatment plant. So actually, the I2O solution was about the only thing they could get in they could get into their network fast enough to save enough water to stop KL from running out of water. They've so far got 25% of their network covered, and they're saving 50 million litres of water every day using the technology. And we're rolling the system out at the moment over the rest of the network. By the end of the year, we should have 75% of their network covered, and the target by the end of the year is 91 million litres per day saving, which is the same amount of water as produced by a reasonable-sized water treatment plant. We also reduced the bursts on their network by 48%. They've done some very careful studies of the burst rates on the I2O DMAs. They come down 48%, which is a massive saving for them. And that's something we didn't predict. We knew we'd have an impact on burst rate, but 48% was a very, very good result. Affinity Water, formerly Veolia, Thames's neighbour in the north of London, has installed I2O technology widely across their network, and they've seen a 75% reduction in burst rates on the zones where they put I2O. And that's reduced their operating costs for managing that part of the network by 80%. Another example of where we've installed our solution on the pump is the first first pump that we've installed the solution on in Manila, and we've reduced the energy consumed by that pump by 20%. And that's because by managing the pump output pressure automatically and making sure it's the right level, just what is required by the network, but not more, they're able to pump at lower pressures on average. And we've also dropped the leakage, so they're pumping less water. And all that's added up to a big energy saving. And Manila Water are about to roll technology out across their other 40 pump stations in Manila. So the company was founded in 2006 with 2 million of angel funding. We've since raised 14 million of VC money in 2 rounds, and we're likely to do another round in the next 12 to 18 months. Since our first proper revenue was in 2010, and we've been more than doubling our revenue each year since then. Ken asked me to mention our business model. Our customers buy the hardware, which is installed on their network. Then the software is then provided as software as a service, which they pay annual fees for. So the more hardware we get in the ground, the more customers we have, the more the software service fees build up, so the more our recurring revenue builds up. We think we're in about a 500 million market for our technology, and I know in the Cleantech industry that might look a little small compared to solar and wind and other things, but we're currently the leaders in this market, and we expect to grab a decent share of this market over the next 5 to 10 years. So if anyone's got any questions, I'd be very, very happy to take them.
What is the typical sales process for your?
Well, always a trial still. Yeah, so fortunately we can trial at quite a small scale. So we can do 1 or 2 DMAs, or 3 or 4. So typically they try it on a small area of their network, and I think probably why our sales cycle is still quite long, or why it's perhaps not as long as some other technologies, is we can show the results within 2 weeks. So we trial the system, they can see the leakage come down in 2 weeks, they can measure it, and then they might try the next step might be 20, 30, 40 systems. And then if that goes well, then they roll it out across their network. So we can do it in stages. So. Yeah. Sorry.
The concept actually is quite simple.
Yes.
Control the network. What prevents other people from doing the same as you? How can you stay ahead?
Well, it's actually perhaps a little more difficult than it looks. I mean, we've had to come up with quite a lot of different pieces of technology to make the whole system work. Particularly, we've had to come up with some very innovative ways of controlling the PRVs, because there's no power at the PRV site. So we've come up with a special pilot valve which we retrofit onto the PRV. That's patented. We need a lot of maths. We need a lot of software expertise to develop all the algorithms. We've had to develop some very low power electronics, because they need to work in a very harsh environment on batteries for long periods of time. So we've had to develop quite a number of different technologies, and so I mean, we will get competitors and people will catch up, but I think they've got quite a few barriers to overcome to catch us up. And we've also been able to patent the system, and we've been able to patent a number of different aspects of it, so that will also slow people down a bit.